Today we're going to be discussing intermolecular forces and specifically going over the difference between two very common mistakes that students make in regards to which molecules have which intermolecular force. So we know the saying hydrogen bonding is FO and N. So it's H bonded to FO or N, right? Now, when we draw these out, so let's start. Carbon goes in the center. You should have plenty of practice drawing these. It's going to bond with an H, put the F over here just because I have more room. Doesn't really matter. An H there. When carbon bonds with these guys, well, there's an uneven, or there's more atoms than just 4, so you can't do it the normal way you would do it. What you end up having to do is bond O to the carbon, oxygen to carbon, and then oxygen to the hydrogen. Now, if you bond the hydrogen straight or up or down, it's not going to really matter. So when we draw the Lewis dot structures, it looks like this. I guess I'll put F up now. Doesn't really make a difference. And again, there's polarity arrows. I'm not going to include that. But the key is the intermolecular force present. So this molecule, if we draw our symmetry lines, is clearly asymmetrical and polar. So is this one. It fails dramatically in one way, and it actually works in the other, but still asymmetrical and polar. Now here's the trick. In order to have a hydrogen bond, you have to have F, O, or N bonded directly to the H. Since the F is not directly bonded to the H, this one is going to have dipole forces, and this one has the F, O, or N bonded directly to the H right here. So this is hydrogen bonds. Now, another common mistake. This bond right here is often mistaken as the hydrogen bond. It's just a polar covalent bond, as is the bond here. These aren't the actual intermolecular forces. You get an intermolecular force when this happens. So here's one molecule. And when there are two next to each other, because again, one end is positive and one end is negative, you get an attraction between two different molecules. That attraction is the hydrogen bond. It's an intermolecular force. This is technically called an intramolecular molecular bond. So this is intramolecular between two different atoms of the same molecule, and this is intermolecular between two different atoms of different molecules, and that attraction is the intermolecular force. The same goes with dipole. If you had an example of two dipole, I'm going to draw a more simple example. HCl. Try to keep my color scheme the same. So there's one. Another HCl could do this. And then this attraction is called the dipole attraction. It's not the actual, the common mistake is to think that it's the bond itself inside the molecule. It's really the attraction to a different molecule. And that's all I wanted to go over for this video. I'll make sure you can see the whole thing first.